For decades, scientists have searched for deeper explanations about why our universe works the way it does, and whether it's the only one. Two of the most fascinating theories take us far beyond ordinary physics, suggesting that reality itself might be far stranger than we imagine. String theory proposes that the universe is built not from particles, but from tiny vibrating strings that create endless possibilities for other worlds. Meanwhile, the holographic principle suggests that everything we see, stars, galaxies, even ourselves, might just be a projection from a hidden two-dimensional surface. Together, these ideas open the door to multiverses shaped by invisible dimensions or projected realities, reminding us that our universe could be just one version among countless others. Hungry, hungry universe. The universe has long been thought to expand because of dark energy, a mysterious force pushing space apart, though it has never been directly detected. In 2023, scientists from the University of Copenhagen and the Tokyo Institute of Technology suggested a new idea. The universe may actually be absorbing smaller universes as it drifts through space. Like a growing blob, it swallows others, creating the outward pressure we see as expansion. This theory could also reshape our understanding of the Big Bang, suggesting that our universe once merged with an older, larger one, causing the sudden burst of inflation. Mathematical multiverse. The mathematical multiverse takes the concept of parallel worlds to the extreme, suggesting that every possible mathematical structure exists as its own universe. In this view, math isn't just a tool we use to describe reality, it is reality. Our universe, from atoms to galaxies, is simply one solution among infinite mathematical possibilities. That means other universes could operate under completely different rules, like gravity pushing instead of pulling, or time looping instead of flowing in a straight line. Some might resemble ours, while others could be so alien that stable matter doesn't exist at all. This theory challenges the idea that our version of math is unique, proposing instead that we just happen to live in one universe where things work the way they do. Bubble universes. According to inflation theory, right after the Big Bang, the universe underwent an unimaginable burst of rapid expansion. But this inflation didn't happen evenly. Everywhere different regions stretched at different rates, creating separate bubbles of space-time. Each bubble could form with its own laws of physics, dimensions, and matter, making it essentially a separate universe. Our cosmos could be just one bubble among countless others, some still forming even today. These bubbles are sealed off from each other, divided by continuously expanding space. The only potential evidence would be if two bubbles collided, leaving behind scars in the cosmic background radiation, faint signatures of universes brushing against each other. Cold spots. The cosmic microwave background, CMB, is the faint afterglow of the Big Bang, often called the universe's baby photo. It should appear random but smooth across the sky, yet scientists have found strange anomalies within it. In 2010, a team discovered circular patterns that some interpreted as evidence of our universe colliding with another. In 2015, researcher Randa Riccari at the European Space Agency stripped away known sources like stars, dust, and gas. But instead of finding near nothing, he found areas up to 45,000 times brighter than expected. These bright patches may be imprints left from another universe crashing into ours, like cosmic bruises. Although not everyone agrees, these cold spots challenge our standard model of cosmology. Simulated multiverse. Simulation theory flips the concept of reality itself, proposing that we may be living inside a computer program created by an advanced civilization. This simulated universe would feel entirely real to its inhabitants, yet could simply be one of countless simulations running simultaneously. Each simulation might have slightly different physical parameters, such as stronger gravity or a different speed of light. Like settings in a video game. Philosophers and physicists argue that if such simulations are possible, it's statistically more likely that we're inside one of these countless copies rather than the one true, real universe. This makes the simulated multiverse not just science fiction, but a serious scientific consideration. Quantum entanglement. Quantum entanglement is one of the strangest concepts in physics, where two particles become so deeply linked that they behave as a single entity, no matter how far apart they are. When one particle is measured, its entangled partner instantly reacts even faster than the speed of light, challenging our basic understanding of how information travels. Before measurement, a particle doesn't have a single fixed state, but exists as a range of possibilities. Some physicists believe that when a measurement is made, every possible outcome actually happens, but in separate parallel universes. For example, if a particle's spin is measured as up in our universe, another version of you in a parallel universe measures it as down. This suggests that entanglement might not just link particles, but also hint at the universe itself splitting into different branches, each containing a different outcome. While not proof of parallel universes, it offers a compelling way to interpret quantum physics as pointing toward realities beyond our own. String theory, multiverse. String theory suggests that the basic building blocks of the universe aren't tiny particles, but vibrating strings of energy. The way a string vibrates determines the type of particle it appears, as similar to how a guitar string produces different notes depending on how it's played. For string theory to work, there must be extra dimensions beyond the three we see, but these are curled up so tightly that we can't detect them. The shapes of these hidden dimensions, called Calabi-Yau manifolds, change the laws of physics, like different folds of origami, creating unique structures. Each fold represents a different possible universe with its own physical rules, meaning the multiverse could be a vast collection of these possibilities. We live in one that supports life simply because only such universes allow beings like us to exist and ask these questions.